Hi everybody. I've got some slides on linking customer needs to product requirements and robust design. Hopefully you'll find this interesting. What we're going to do is go through a few tools that you can use to ensure that indeed you understand customer needs, that you have comprehensive product requirements that link to those needs, and then you can use product requirements to your advantage for ensuring robust designs. What is a robust design? It meets all requirements uh, virtually 100% of the time, or at least within the specification limits that you establish. And so we'll go through some tools that help enable that. The next slide is just a little bit about me. If I can get this to, there we go. So I'll just say we won't spend a lot of time on this, but my background includes certifications in Lean Six Sigma, Design for Six Sigma, project management. I help with product and process excellence, Lean Six Sigma, Design for Six Sigma, project management offices, and product lifecycle management. And so what we're going to discuss today is kind of along the lines of the initial part of the product lifecycle, where you're determining, what the right product is, and then you're helping establish how we build the product right. So I'll get to that in the next few slides. So we're not going to spend a lot of time on this, but just a little bit about me, and then I'll just go into the next slide, where, as I mentioned, we're going to understand how to link customer needs to product requirements, and we use a tool called quality function deployment to do that. Determine the relative impact of product requirements on the customer. So, a product has to meet all requirements, but are there some requirements that it really has to meet that really impact various customer needs? And those would be critical to quality requirements. And so there's a way to determine what are the most impactful requirements. And so there's again, a product has to meet all requirements, make sure you have good comprehensive requirements, but what are the ones that have a higher relative impact on the customer? And we'll go through some tools to help establish that. And then, so then part of what we're doing here is requirements validation. So we're going to leverage our knowledge of valid requirements to help ensure robust design. And so, doing that homework to know exactly what the product functional requirements are, what the most important product functional requirements are, and then we could optimize our design with that knowledge. Right. So I mentioned the quality function deployment tool, also known as House of Quality. And, I could spend easily maybe an hour, half hour to an hour on the use of that tool and some of the, I guess you'd say, nuances of the quality function deployment tool. But, we're going to just dive right into an example. Probably the best way to understand it is to just see an example and kind of discuss what that tool helps you understand about your product and about the customer needs. And so, yeah, so we're going to ensure our understanding customer needs. And then also with this tool, what is your competitive environment, right? So do you have other products out there that you're competing with? And so you can kind of use the tool to understand where your competition is at, and then have a competitive design strategy, and ultimately design for customer value, right? So because the value has its origins in meeting customer needs. And so start with the needs, optimize the design for customer value, maximize value, and then we always want to consider minimizing cost. So when we talk about an optimized design, ultimately that's what we're doing. We're maximizing value, minimizing cost. And then we'll talk about design failure modes and effects analysis. So at DFMEA, we want to leverage our knowledge and of the requirements and the requirements that are the various highest priority are something that we want to ensure robust design, that we're designing according to not just all requirements, but also requirements that have the most impact on customer needs. Right, so we'll go move forward into the tool, quality function deployment tool. So there's a graphic here on the right-hand side, and so we'll discuss this in more detail in the next couple of slides with an example. But really, it's a matrix where on the left side, you have your customer needs listed, and then across the top, functional product requirements. So you're going to use this basically a correlation matrix to link requirements to needs. And then with each of those requirements, what are your design targets, and how are you going to measure that requirement to know that you have a quantifiable target, right? You have a quantifiable measure. So ideally, if you're performing some sort of verification, of course, you're going to put a scope or some sort of sensor or something to measure that the product functions to within the specification limits. So when we say targets and measurements, well, those would be, spec limits and the units of measure. And, you can't improve what you can't measure. You can't really say whether it meets requirements if you're not measuring it, right? So, so in each of the columns of this matrix, you're going to have, the requirements and the targets and measurement. And then over on the left side, the right side, excuse me, you could include information from your competitors. Okay, so if you're looking left to right, you've got customer needs, and you might ask, okay, well, what is so great about this competitive product as it relates to those needs? And so you're kind of gathering information there to understand the competitive environment for your product. And then you're also, listing, okay, what does this product have to do with the product functional requirements and linking those requirements to needs. So I kind of went a little further on this slide without the example than I intended, but it's good background information when we get to the example. So yeah, it's a method for structured product planning and development that enables the team to specify customer wants and needs, and then evaluate each proposed product or service capability systematically in terms of its impact on meeting those needs. So it's a little long-winded. There's an author, Lou Cohen, who clarified or provided that summary of what a QFD method is. You could go online and buy books, and it's pretty slick. Actually, it's this is one of the more fun tools to implement and to use. It really helps to establish a comprehensive understanding of what the customer needs are and what your product has to do to meet those needs. Right, so structured yet customizable. The thing about some of these tools also is that there's a degree of creativity, and we're going to actually exercise some of the creativity in the use of this tool, and for having a data-driven understanding of the product that you develop. So it's both qualitative and quantitative, right? So data-driven, meaning we're going to assess the impact of needs, of requirements on customer needs. And so there's, there's sort of 1 to 10, scales in here that you'll see, but also, okay, data driven, right, as far as targets and measurements and, specification limits and what we're going to target in the development of our product to optimize the design. So the other advantage is, all the stuff is all on sort of one sheet of paper, and you can kind of get so much information from this one tool once it's filled out. And then, of course, like a lot of tools, you want to continue to put your updates into it as you gain a better understanding of the product and the customer. So there's various functions, sets priorities and measurable goals. I mentioned that. Information to drive product development, and focuses on what the customer truly wants and needs. And, so I mean, you might have, used a product and said, God, I just want this product to do this, and it's not doing it, and it's frustrating. And so, there's some things that products should fundamentally do and do really well, and when it doesn't, of course, it's pretty frustrating. All right, so what we're going to do is we're going to go right into an example and spend a fair amount of time on this slide. Let's see here. All right, here we go. So this example, so we could get into the weeds on this and question each of the individual requirements and ratings, but bear with me on this, and we could kind of start at the 30,000 foot level and go down to 5,000 and back to 30,000 and just sort of take all this in. But so what this is, it's an example is a printer, and if you went to the customer, and this is on the left-hand side, the far left, you said, well, what are your needs? Well, we want this to always provide a print. And by the way, sometimes we get blank sheets, and so we don't want blank sheets. And boy, paper jams are a pain. And this thing can't jam. It's that's a problem if that happens. And we want the print to happen at a certain rate. And by the way, if it does jam, we want that to be easy to clear. And our paper, the specialized paper, it's valuable to us, and we don't want paper damage. And we low ownership costs. So we've got to, once we get this thing, we don't want to have to keep spending money on it. And the print appearance, clarity, definitely is a need. And then the actual size of the unit, this floor space it takes up. And so, and if you notice that these needs don't really establish a requirement per se. It just sort of says, hey, the more compact, the better. Okay, great. And then, we've had these printers and they get beat up, and, if it's scratch resistant, that'd be nice, because, we expect to have this thing for a long time. So, think about that left column, and that's voice of the customer, right? They're not specific about requirements. They're just talking about needs. And so, the deliverable there, and so now we're get into sort of the functions that you might expect to go out and get this information, would be maybe marketing or product managers. And so I kind of characterize that as a market customer assessment. And sometimes the term market requirements is used. And I'm not so sure the market necessarily provides requirements. The market is an environment that provides needs. And so to me, the goal is to stay in the needs domain, right, in the environment, and just sort of understand that environment in which the product needs to perform. And so we'll get to the functional product requirements, but very important to understand the needs and the environment in which the product resides. Right. So what we're going to do is going to go to the far right and look at sort of the competitive products columns. And so I just threw some made up names in there and some ratings. And so the customer should tell you, hey, we really like this product, this competitor product, or that competitor product because it's superior. Like customers never experienced paper jams with one product or another, right? Or they never get blank sheets and et cetera. So yeah, so now we've got, customer needs highlighted and understood. And then, hey, what's good about this other, competitive product that seems to be, beating us in say market share, right? And so we've got information on those competitive products. We kind of highlight, maybe all the scale 1 to 10 stuff. And if you go, so you like highlight all the 10s and say, well, we've got to beat one model at one need, highlighted paper jams or ownership costs, so you're establishing basically a benchmark here for competitive products. Now you can see that there's numbers across the bottom, relative importance. So what we're doing in the center there, we're clarifying our functional product requirements, and then we're just doing an impact ranking. And here the impact ranking is using a 1-3-9 scale. And so the 1-3-9 is meant to establish like a high degree of separation between the high impact. So 9 is a direct and strong correlation or impact of that requirement on the need, and then 3 is moderate, and 1 is minor impact, but some impact, but not very high. So this is, I talked about creativity. Yeah, you can probably play around with different scales instead of 1-3-9. Your importance ranking, scale of 1 to 10, relative importance, right? So 10 is if the 10 is the most critical, then what's a 5 and what's a 6? So just like failure modes and defects analysis, you kind of want to have some criteria and kind of play around with your scaling here. But nonetheless, so what you're doing is you're going to take the sum of the product and just take that, for example, this first column, 6 times 3 plus 2 times 3 plus 8 times 9 plus 4 times 9, and etc. And you're going to get a relative importance ranking. In this case, the misfeed rate per million, this is a requirement we established, has just a relative importance of 240. Just taking the sum of the product, right? And then multi-feed rate is, so that's kind of too many pages kind of coming through, and that's where you might get a blank sheet or you might get a paper jam. Definitely direct and strong correlation with blank sheet if you have a multi-feed condition, and maybe a little less impact of that requirement on paper jams or the rate of printing, etc. And so again, so the sum of the product there is 120 and so forth. Are there any questions up to this point? Go ahead and put those in the chat. But you could sort of see the measurement units. So how are we going to measure that requirement? And we're going to verify the design against those requirements. We're going to have both a target value and an upper spec limit. And if there's a lower spec limit, sometimes, the rate, we want it to be some max value, like the upper spec limit, but anything less than that is better. And then we could put, a target value, and what are we going to target for that particular functional product requirement. All right, so I mean, with this, just sort of this particular product, now we know a lot about, what the product has to do, what it has to do really, really well. We want to minimize the misfeed rate more than anything else. And then we definitely want to minimize the jam rate, because that's the, some of the things that impact the customer the most. And remember, it's not just about a single impact rating against one need, but you can see that in some cases there's multiple needs that are impacted by that functional requirement. And so I'm going to probably just go to the next slide. Well, okay, so the next slide actually is, I'm just highlighting what I just discussed, where you've got, some critical quality requirements. And critical to quality, meaning there are some requirements that really impact multiple customer needs. And so we're going to sort of highlight those for just optimizing our design, and also analyzing our design for robust design, and helping to ensure those requirements are met or even exceeded. And so let's talk about product requirements. And the product requirements are really essentially the output at input conditions. And so the product, what the design provides, right? So when we say functional product requirements, what the design provides in order to meet customer needs. And so with that framing, let's go to the next slide, and we'll talk about one of the things we could use, one of the ways we could use this matrix to our advantage to make sure we have comprehensive coverage of requirements, right? So what if you have a need with no requirement? So you look across and you say, oh, there's no impact of any of the requirements on that need. Then you're going to say, well, maybe we need to add a requirement that does meet that need. And so now we know what we have to design our product to meet all needs, right? So that's possible. Look across. There might be a need with no requirement. There might be an unnecessary requirement. You might say, well, the product has to do this and that, and you've got all these requirements listed in each of the columns. You say, well, what need does that meet? It's like, well, maybe we don't need that requirement. It's unnecessary. And we want to make sure that some relationships haven't been overlooked. So yeah, so each customer needs to have at least one strong requirement. We're offering functional product requirements without at least one strong relationship have a low rank. So so you should have at least a high rank on each requirement. And do you have too many or too few relationships? So you kind of look through and like, does it all make sense, right? And again, I think there's a real advantage to having all this on sort of one sheet of paper, and have a comprehensive understanding of your product and how customer needs are met. Okay, so it's a really neat tool. let's talk a little bit about validation. So you know, this matrix, you know, you're sort of aligning, understanding customer needs with what the design shall provide in order to meet that need. And so to me, that's a form of validation. Um, so remember, validation is the completeness and correctness of product requirements. And so we want to build the right product, which is, you know, validation, and then build the product right. We want to verify the product against valid requirements. And so if you've got an unnecessary requirement that doesn't link to needs, it's not a valid requirement, is it? If you've got, you might have the other way around, requirements that, let's see, you either have too many or too few requirements. I'm thinking out loud here. So, you know, too many, you might have requirements that don't meet needs well, you also might have, you know, missing requirements, of course. And so you've got to add that requirement. That's a form of validation. So now you're saying, oh, we need this requirement because the need is there, but we didn't specify it. So now let's specify it. That's the form of validation also. So what is a requirement, right? A statement of what the design shall provide output at input conditions. So remember, think in terms of output at input conditions, you're providing, the design provides some output to meet a customer need. And so that's kind of what we did in the matrix, right? We were saying there's some impact of those requirements or output, what the design provides on those customer needs on a scale of 1 through 9, et cetera. And we're doing that sum of the product to see what the biggest impact is. And so this is, I think, a very good framing for requirements, what the design shall provide output at input conditions. So I think, you know, that's where the sort of separation, if you will, customer needs, you know, really understanding that environment, not getting into the requirements realm, right? So when you say that if you have a, you know, marketing or product manager say the design should provide this, well, but what is the need, right? So I'm just suggesting that you know, one deliverable called the market assessment stays in the needs domain and doesn't establish requirements per se, or design. And sometimes a, you know, marketing will say, well, it's got to be bigger than a bread box. It's got to be a certain size. Well, why? You know, so what need does that meet? Well, the customer wants to minimize floor space. So, okay, good enough. And so, so, you know, you can't forget that, like, explanation of, you know, what the design shall provide and what need that meets. And so that, you know, that also ties back to this quality function deployment matrix where you're validating that, right? So also statement of what design misfeed rate. So we have a requirement called misfeed rate shall be less than 100 per million copies. And our QFD matrix helps ensure this requirement is tied to customer needs, right? So yes, it's correct and, you know, maybe even obvious, but maybe it's not entirely complete. So the question on that one requirement is what would make that a valid requirement, right? And so if anybody wants to take a guess and put it in the chat box, feel free to comment on that rate, misfeed rate, right, shall be less than 100 per million copies. So what is that missing? If anybody wants to take a guess at that, feel free to go ahead and put that in the chat box. So one of the things that that's missing is input conditions, right? So you might include, for example, the type of paper that this printer accommodates. And so the misfeed rate might be somewhat dependent on the weight of the paper. And so you might have in your requirements, hey, this thing has to operate under all these requirements with a paper weight of 50. I'm not familiar with paper weights or paper sizes, right? So it's got to accommodate, you know, 8 by 10 and 11 by 14 or whatever. So that is an input condition. You're putting paper in and you're getting, misfeed rate or conditions, you're getting outputs that might be somewhat dependent on the paper you put in. And if you put fly paper in, that's going to be a problem. So you really should have that understanding of both output at input conditions. And so that's one of the things that would be a valid requirement, is making sure that both the input conditions are understood as well and built into the requirements. Right. And then another point here is, okay, so we came up with a value of, 100 per million copies or prints. And I'm not familiar with high-speed printers or that market, but 100 per million as an upper spec limit, where does that come from? Well, maybe you get some competitive products and you run them, and you have a benchmark. So this benchmark is just based on needs, but you might take the most competitive product, like the Xerox product, which hardly ever paper jams according to the customer, and then you run it and you get competitive intelligence to say, wow, if we really want to be competitive, we want our upper spec limit to be 100 per million, and that would be competitive with that product. And so that would be a form of validation, right? So you're making sure the requirement is complete, correct, and that it comes from somewhere. And in this case, I'm suggesting that that value should be sort of fine-tuned and could be maybe benchmarked against other products you're competing with. Okay. So I thought that would be a good topic to kind of add to this. And it is this process of robust design, really does hinge on valid requirements. Now, so remember, we got some values from our critical quality requirements and our relative importance. So this is a graphic that has the misfeed rate at 240, the sum of the product, jam rate, multi-feed rate, maintenance interval, damage rate, print rate, right? And so we've got some values to work with. And so how could we use those in another tool, like a design for failure modes and effects analysis? So the DFMEA, we established severity criteria, and sometimes it's kind of arbitrary. It's maybe 1, 3, 1, 3, 5, 7, 10, or 1, 4, 7, 10. We just have some spacing between each of the different failure modes and severity numbers that we put in there. And so what I'm sort of suggesting here is that, well, we've got this thing, we've done a quality function deployment, we know what the most important needs are to the customer, and then we're saying, well, what's the severity if those needs aren't met? And those could be sort of tied back to this analysis. And so here I'm just suggesting that your severity criteria could be sort of spaced out and somewhat correlated with the impact of those requirements and those needs. And so I've got a little bit different severity criteria where the 10, the worst thing that can happen is a misfeed paper jam that's more difficult to clear and potentially damaged paper would be sort of the highest severity as it relates to requirement not being met, right? And then clearable paper jam, no damage paper, maybe an issue requiring more feed is more frequent maintenance, right? So because that came up as important to the customer. Now, you could, if you sort of think out loud about this, what if the customer said, well, the only thing we care about this is it goes fast, and if we clear it, it's not so much of a problem, or I mean, the needs could be different, ranked differently, and then these bars on the top might be all different, and then your severity criteria might be different. So the thought here is that, well, maybe with our knowledge of needs and relative importance, we can kind of tailor the severity of any given requirement not being met, right? So the QFD knowledge helps establish severity criteria and weighting. So now we're going to go into a design for failure modes and effects analysis, and we're going to ask ourselves, what's the product requirement under investigation? What is the potential failure mode? And then what's the effect? And the effect is, hey, it's an impact on the customer. And so remember, that ties back to our needs in our quality function deployment matrix. We've got that knowledge now. It's all that's sort of there on that sort of single sheet of paper, which is great. And so what I've kind of took a shot at here was, and I don't know a lot about printers, but so I sort of went ahead and filled out a few lines from this, and we're going to analyze the failure mode as it relates to the product requirement. So this is great. We've got valid product requirements, and then we've got our statement if the design fails in a way that we get excessive misfeed rate. The effect on the customer is significant. Paper jam requiring removal of damaged paper. So it's sort of a double whammy. You've got the aggravation of clearing the paper jam, and you've got valuable paper that you've got to throw out. So that gets the highest severity ranking. So we're going to give that a 10 in the severity column. So now we're going to analyze our potential causes. And so again, this example, you might have, there's some parameters. We're kind of getting into design parameters, or sort of requirements inside of this complex product, right? So you've got so I took a shot at some for design parameters that could be potential causes of those failure modes. So I've got excessive retard friction, retard brake force, inadequate retard brake torque. So brake torque, right, could be either too much or too little. And so I just threw in, hey, this is based on our experience. You've got engineers that would say, hey, this is likely to occur because it's been a problem before. What do we do about it? Well, maybe the controls are torque sensor accuracy and reliability. So that it's this torque sensor is a critical component, and its parameters, accuracy and reliability, is something we want to optimize. So now we know aspects of the design parameters and components within the design that we want to optimize. And so now, what would you do about something like this? Well, you have some potential actions, all right? So you might have redundant torque sensors. So you can build in redundancy or have some sort of fault detection if the torque sensor fails. Maybe you have maintenance actions to ensure that that sensor stays within its accuracy parameters, right? So you have a fault code that comes up before the paper jams occur. Or this is something you focus on for reliability. So you maybe have a reliability requirement for this component, or you perform some reliability testing. But in the end, what you're doing is you're drilling down to understand where you really need to focus in this complex design to ultimately make sure that you have a robust design and that your most important requirements are addressed or optimized with a robust design, right? So hopefully that makes sense. It all sort of fits together. So just to sort of summarize, you want to assess the market for your product and emphasize customer needs and a competitive advantage before product requirements, right? So I'm sort of calling that a market assessment document, not market requirements, but a market assessment, and really understand those needs, perform quality function deployment, and have really good comprehensive product requirements. So those are a couple deliverables, the QFD and the product requirements document. And again, all product requirements need to be met, but what we're focusing in on what are the critical quality requirements and the thing that has the most impact on customer needs, and that we want to optimize the design for customer value. And then, of course, the last deliverable is the design for failure modes and effects analysis, and design enhancements or actions to ensure robust design. So we understand needs, we understand impact of requirements on those needs, we understand requirements, and then we understand potential failure modes of those requirements, and we have actions to address those potential causes of failure modes. And it all sort of fits together. So I'm going to stop right there. That's the last slide. Does anybody have any questions? Go ahead and put those into the chat box.
While people try to find their keyboards and stuff. In practice, what do you see as the hurdles to doing a QFD?
Well, I think that in my experience, product managers want to essentially determine the design. And then, they want to say, well, and it's somewhat easier to do. It's a little more tangible. It's like, well, the product needs to do this, or that last product had that, and this is going to be better. And so the biggest challenge to me is that that everybody wants to play in the design domain, right? And that, oh, this will be better, that'll be better. Let's add this feature, and there's sort of a pile on of they all want to kind of add their ingredients to the design, but really, the emphasis should be on requirements first. And understanding, how the design is used in the marketplace, or maybe misused, and focusing on intended use. And then we can't forget about unintended use. So all those critical questions upstream of the design is really kind of hard to get even product managers or marketing people to focus on.
And Tony, I think, is also chiming in something similar here. Finding designers not willing to step up to declare effects and severity.
Yeah, good point. You know, I mean, you just have to find a consensus and well, declaring effects and severity. Yeah, so I mean, your knowledge of customer needs should um, help that improve that understanding. And then designers actually should help, uh, you know, um, with their product knowledge, understand potential causes. So like, oh yeah, you know, this could fail, and if that does fail, then it'll have this effect. Um, Participation in DFMEAs. Well, I do think it's a fun tool, and it is important to frame it right. I've participated in DFMEAs that were sort of done incorrectly, in that um, the client sort of threw well, of course, I wasn't responsible for that. It was it was done by somebody who didn't really know how to do good DFMEAs, and so they threw their hands up and said, "Well, we're not really getting any real value out of this." But the framing of the cause, potential cause, and impact and effect, and a lot of things they did in there were sort of done wrong. So I mean, I would say a good example of a DFMEA, and it's a tool. I mean, I'm a big tools guy. I think it's kind of fun and interesting to see what comes out of it.
Well, yeah, Rob, just because you think it's fun isn't going to get two old school designers to show up. I mean,
Fair
it's got
enough.
to be something for them. It helps them prioritize. It helps them, focus on what's the critical elements of the system. It's
Yeah,
it's a prioritization tool,
it is.
and instead of battling the other department for funding, let's figure out where it really needs to go collectively and get it some alignment on it, so we're not at cross purposes. That doesn't always work. But to your question, Tony, it's what's in it for them. And if you
Yeah,
can't answer that question, you're not going to get them to show up. It doesn't matter what the meeting is or the deal, but if the spending half a day in an FMEA session has got to yield something of value to all the participants, otherwise it's not the right tool at that moment.
right.
Um,
And you know, the emphasis being on ensuring customer value. The more value we're providing to the customer, the more successful everybody will be in
yeah,
in that product in the marketplace. So thanks for that, Fred. Yeah, good point.
yeah. Yeah, you're too much of a tools guy, Rob. Uh, well,
I'm
Greg's got
one of
a
those.
yeah,
I'm
Greg's got
a,
a question for you
yeah,
there. That's
sure.
good.
Competitive analysis ranking. So I, I think on all these rankings, it's sort of like start with what is the very best, and then what's relative to that. So so these are always just sort of relative rankings, and so I might the best I could say is establish a base case, and if you use a 1 to 5 or 1 to 10 scale, so start with what is the best, and think about that. It's like, well, that's not quite as good, almost as good, so that's an 8 as opposed to a 10, and
Well,
so that would be
yeah, I
one.
don't think yeah, Rob, I think there's not like a formula for it. It's a
Correct.
combination. What's the most important to the customer? What is the so if paper jams is we just can't do this at all, just never do it. This number one priority. And your competitor that has no paper jams whatsoever has 90% of the market. Well, that might really be top priority, you know,
Yeah, yeah,
but it gets complicated as soon as you say, well, we want it to be low cost also, because that's the second most important thing to the customer. So we're going to trade off the cost of getting no paper jams with it being a low cost part of the marketplace. And you might be at slightly different slices to the market. You might be at slightly different roadmaps for your technology evolution. So it ends up being subjective. The important part is that team in that document then align your organization. So one
Yeah.
person is not working on, no way we're doing any paper jams, we're going to spend a fortune doing that, and the rest of the team is, that's not the priority.
Optimizing something else. Yeah.
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 So it's a tool for, as much in FMEA is like that too. It's a tool to avoid these working at cross purpose.
That's right. That's right. Yeah. So good question though. I mean, it's somewhat, so there is some subjectiveness to it. And surveys is another way you could potentially do it. So again, that's where, you could use some creativity, uh, scale of 1 to 10 stuff, or surveys, or I mean, even just educated guesses is better than nothing. And it'll force you to sort of take a closer look at what competitors are really, what you're up against. I
So,
remember. Go ahead.
so Rob, one question for you do you think the iPhone had a QFD analysis?
Well, it's funny you mentioned that, because I remember Steve Jobs saying, "Well, we had customers tear up their plans," and so if that's the case, that's actually not customers. I'm sorry, competitors tear up their plans when that came out, and you know, if they really did a good competitive assessment and they were developing a product and that came along and they said, "Uh-oh, let's update our QFT." They say, "You know what? We're not even come close with this design. Let's just stop right now." You know.
Well, you know the quote from I think it was Henry Ford that said, if I would have asked my customers what they really wanted, they would want a faster horse.
Well, fair
So
enough.
it's that's why it's I think there's a place for it is when you've got a product like printers, inkjet printers, for example, which I do know quite a bit about, having worked with them for a long time. They the ability to print, say in your office or your home, is now got like a 30+ year history or 40-year history. And so there's lots of market
Yeah.
analysis, there's lots of assessments of what's needed and not needed. There's all kinds of knowledge about what's going on, so that that next printer is not likely, unless you've got a brand new technology or brand new way of getting stuff on paper,
Yeah.
um, then it's QFD is perfect because you've got a good solid base to start with the customer needs. Whereas if you're Steve Jobs, you don't ask the customers, but you also have very strict control of what the requirements are, what your designing is.
Right. Well, I have a couple thoughts. One is Henry Ford mentioned a horse, which was a design solution, right? So he wasn't just talking about like he
Well, if
he
you want
wasn't
to,
just talking about customer needs.
yeah, he's talking. Customer needs is I need to get here to there faster. Would have been one of the requirements,
Yeah. Well,
and
one
they
of
would have asked for a faster horse. I think that's what Jobs did. Is these people want to communicate, and we have this infrastructure available. Let's do it differently. And where Ford was saying, "Well, I'm going to make it cheap so everybody can do it." It's not as cheap as your own horse, although even just having chickens in my backyard is those are some expensive eggs. So I'm because the food for the chickens is pretty expensive. But
yeah.
the idea is that the customer needs might not be on an existing product line. They might be on solving a problem. Customers
Uh,
need to communicate.
right.
Customers need to travel or transport things.
Yeah.
Those kinds of things. And then I've seen it done where it starts at that point,
Yeah.
and you don't, and so it's skipping the step is like, I'm going to make a printer. What do you need for this? Well, let's not offer a printer as a solution. How do you communicate using paper,
Right. Right.
and then solve that problem? And what are the needs for that? And things like clarity and it's stable, it doesn't smear, stuff like that will all come out, but it
Sure.
goes to a different level.
Right. Right. Yeah, there was an interesting documentary back to your observation about Steve Jobs and the iPhone, and was it the Palm Pilot, right? And they
Hmm.
stuck, they were determined to make that design work.
Yep.
They were very design focused and, you know, well, you can see how that turned out. I mean, they spent a lot of money and never got to where, where the iPhone was, obviously. Um,
Yep.
and yeah, so yeah, take yourself out of the design environment for a minute. And I think that would be, it's
Which is really hard to do for designers. So you do need,
it
people that, you know, for existing products is people that understand that market and the design, the requirements from the customers. And having those people in the room, because like you said, designers would, like, well, we can make it go faster. And it's like, well, if that's not a priority and it increases the number of paper jams,
right,
then we might have missed the boat. Let's understand which is
right,
important and balance them out. I think that's where this tool really shines.
exactly,
Um,
exactly right. Yeah.
one of the Yeah,
We're
we're
over an
running
hour.
yeah,
Do you
we're
want
running up to it. One last thought here,
yeah,
Rob, is
please.
that the oh, now I've drawn a blank what it is. I'm having my own, I need more coffee. But the idea is that one of the reasons FMEAs and QFDs and other tools work, and it's usually and it should always be a team event, is that you start to realize what questions you should be asking. And then you can go
Yes,
find the answers. If you don't know what you're looking for, it's really hard to find it.
yes.
And so I think that's one of the things you didn't mention, is that it's a way for us to peel back the curtains of fog of uncertainty and figure out what do we really need to do.
Yeah,
Whereas
asking the
it's
right questions, right? Yeah,
yeah.
absolutely. Yeah, putting your thinking cap on and saying, well, wait, yes, I see that, you want the design to do this, but why?
Mhm.
Where does
And
that
what's
come
the
from?
trade? Yeah, where's that come from, and what's the trade-offs and all that good
Yeah.
stuff. All right, good. Well, thanks so much, Rob. We're up against the hour. Um, I
All
know
right,
we've got
everybody. I hope that
more
gives you
stuff
something
coming
to
on.
think about. Yep.
Yeah. And
Absolutely.
Rob's got an article series on Ascendo, so he's available through those articles, those comment sections. He's got an about page with plenty of ways you can get in touch with him. I didn't try to find you as on a search, because I don't know how many Rob Allens there are in the world, but if you find a Rob Allen with Six Sigma stuff in it, that's
Right.
you.
Robert Walter Allen. Yeah, thank you.
There you go. All right. Well, cool. Thanks so much, Rob.
All right, everybody. Have a good day.